Hi, this is Mr. Mack. This is going to be a concept video about evaluating the sines, cosines, tangents of special angles. I need to start out, however, by talking a little bit about periodic function. Now, the idea of a periodic function is one that after a while repeats the same thing over and over and over again. If we had, for example, x and f of x, and we looked at values of x, let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's probably enough. And imagine that the values for these started at 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Now, this would be a periodic function because the same values repeat over and over and over again. Now, if you looked at a graph, it would look something like this. We have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 5. Oh, oops. Let's start. I started with 0, not 1. That's why the graph's not working here. Let's try again. 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. So as you can see, these go over and over again. If we connected them with lines, it would look something like this. Now, when you have a periodic function, the same values occur again after a while, over and over and over again. And a lot of times we ask ourselves, what is the period of a periodic function? Well, we have a 1 at 0, and then we have a 1 again at 3. So we would say the period of this periodic function is 3. In other words, it takes 3 units to repeat. Now, the trigonometric functions are periodic functions, and the periods that it takes them to repeat are pretty well known. For example, the sine, cosine, cosecant, and secant of theta have a period of 360 degrees, or 2 pi radians. And the tangent and cotangent functions have periods of 180 degrees, or pi radians. This is kind of important to know, and it will become even more so, even more important as we take a look at what we're going to do next. Now, what we want to talk about now is evaluating sines, cosines, and tangents of periodic functions. So what I'm going to do is I'm going to start out, and we're going to make a chart here. I don't want that to happen. I'm going to make a chart here, and let's just let this be the row for theta. This will be the sine of theta. This will be the cosine of theta, and this will be the tan of theta. and we're going to do 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, 180 degrees. Actually, we'll just go ahead and start another table for that. But now, on the last video, I showed you the unit circle. So let's just take a look at a quarter of the unit circle again. Now, if this is the unit circle, and let's let this point right here be 30 degrees, the ordered pair is square root 3 over 2, comma 1/2. This point, by the way, is the point 1, 0, and it's 0 degrees. This point right here would be the 45-degree angle, and its ordered pair is square root 2 over 2, comma square root 2 over 2. This would be the 60-degree angle, and its ordered pair would be 1/2, comma square root 3 over 2. And then this, of course, would be the 90-degree angle, and its ordered pair would be 0, 1. Now, since this is a unit circle, the radius is 1, then it turns out that the ordered pairs x in each of these ordered pairs is the cosine of that angle, and y is the sine of that angle. So if we look at the sine of 0 degrees, that would be, let's just, 0 degrees is right here, and the sine would be 0. The sine of 30 degrees would be 1/2. The sine of 45 degrees would be square root 2 over 2. The sine of 60 degrees would be square root 3 over 2. And the sine of 90 degrees would be 1. So let's just go ahead and write those in. We get 0, 1/2, square root 2 over 2, square root 3 over 2, and 1. Now, if we moved on, in other words, if we went ahead and continued this circle, 120 degrees would be here, 135 degrees would be here, 150 degrees would be here, and 180 degrees would be here. Now, notice this point right here, the 120-degree angle, this point is the same as this point, except the x number would be negative. So in other words, this point would be negative 1/2, comma square root of 3 over 2. So the sine of 120 degrees, would be square root 3 over 2. Now, the sine of 135 degrees would be the y value of this point. Now notice, y is positive in this quadrant, and it's the very same one as this one, so it would be square root 2 over 2. And the sine of 150 degrees would be the y value of 30 degrees, so we get 1/2. And then, of course, this point is negative 1, 0, y being the sine, we would get 0 again for it. So the values are square root 2 over 2 for 135 and 1/2 for 150, and then of course 0 for 180. Now I'm going to move all of this stuff down a little bit, see if I can get it to move down. There we go, I think I got that. Now, if we wanted to look at the cosine of theta, those would be the x values for this unit circle. And so we would get 1 for the cosine of 0, square root of 3 over 2 for 30 degrees, square root 2 over 2 for 45 degrees, 1/2 for 60 degrees, and 0 for 90 degrees. Now, the thing about the cosine, in the second quadrant, this point has the same coordinate as this point, except the x, we would go left, so the x would be negative. So the cosine is negative in the second quadrant, so we get negative 1/2, negative square root 2 over 2, and negative square root 3 over 2, and then negative 1 for 180 degrees. Now, since the tangent of theta is y over x, it would just be the sine of theta over the cosine of theta. Now, 0 over 1 is 0. Let's look at this. 1/2 over square root 3 over 2 is equal to 1/2 times 2 over the square root of 3. The 2's would cross cancel. We get 1 over the square root of 3. So the tangent of 30 degrees is 1 over the square root of 3. Now, usually we don't really like that, so we're going to rationalize that. We get multiplied by square root 3 over square root 3, so we get square root 3 over 3 is the value that's usually reported for the tangent of theta. Now, for 45 degrees, y over x, anything over itself is 1. Now, for 60 degrees, we get square root 3 over 2 over 1/2, which is square root 3 over 2 times 2 over 1, and that cross cancels, leaving us just square root 3. And then for 90 degrees, we get 1 over 0, and 1 over 0 is undefined. Now, if you look at the second quadrant, the ordered pairs are the same except x is negative for the reference angle in the first quadrant. So the tangent of 120 degrees would be negative square root of 3. The tangent of 135 would be negative 1. The tangent of 150 would be negative 1 over the square root of 3, or negative square root 3 over 3. And the tangent of 180 degrees would be negative 0, which we usually just refer to as 0. Now, the same things could be done in the third and fourth quadrant. Unfortunately, a very noisy herd of students has come in, so I'm going to pause this for a minute and then continue. Hello, I'm back. Now, we're going to go ahead and go on around the circle. So if you'll notice here, as we go on around the unit circle, we have the 30-degree reference, 45-degree reference, and 60-degree reference angle in the third quadrant, 90-degree in the at the negative side of the y-axis, and then in the fourth quadrant, we've got 30, 60, 90 as well. So this is going to be 210 degrees here. This is going to be 225, and this is 240 degrees, 270 degrees, 300, 315, 330, and then of course again 360. So if we want again theta, sine theta, cosine theta, tan theta in let's see, 180, 210, 225, 240, 270, 300, 315, 330, and 360. Now, in the third quadrant, the sine of 180, we have those already, 0, negative 1, and 0. So in the third quadrant, the sine is negative, and so the ordered pair here is going to be the same as this ordered pair, which is the same as this ordered pair, except this one, y, is negative. So we're going to get negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, and negative 1 for the sine in the third quadrant. So what did I say? Negative 1/2, negative square root 2 over 2, negative square root 3 over 2, and then negative 1. And then it's going to reverse negative square root 3 over 2, negative square root 2 over 2, negative 1/2, and then back to 0 in the fourth quadrant. So we have negative square root 3 over 2, negative square root 2 over 2, negative 1/2, and 0 again for the sine in the third and fourth quadrants. Now for the cosine, notice that's the x value of this point, and that's the same as the x value of this point. And notice both of these we move to the left, so the SIGN is the same for the x for these two. So we get negative square root 3 over 2, we get negative square root 2 over 2, we get negative 1/2, and 0, and then positive 1/2, positive square root of 2 over 2, and positive square root of 3 over 2 for these, and then back, of course, to 1 there. So we'll write these in. We get negative square root 3 over 2, negative square root 2 over 2, negative 1/2, and 0, and then 1/2 square root 2 over 2, square root 3 over 2, and back to 1. Now for the tangent of 210 is going to be the same as the tangent of 30 because 1/2, let me grab the finger here again, 1/2 over square root 3 over 2 is the same thing as negative, oops, is the same thing as negative, oh, I don't want that, I want this, yeah. Negative 1/2 divided by negative square root 3 over 2, because a positive over a positive is the same thing as a negative over a negative. And except for the SIGNs, these two values are the same. So we're going to get the same value here that we did up there, which is 1 over root 3, or root 3 over 3. And then we're going to get 1 for this one and root 3 for this one. And this one is still going to be undefined. And now, in the fourth quadrant, though, notice that we had a positive over a negative here, and now we have a negative over a positive. So we're going to get negatives again in the fourth quadrant, which are the same as the second quadrant. So we're going to get negative root 3 here, negative 1 here, negative 1 over root 3 here, and 0 there. And let's just write those in. Negative root 3, negative 1 over root 3, which we know is negative root 3 over 3, and then, of course, 0. So notice what's happening when we go for the tangent values from 0 to 180 repeat from 180 to 360. That's why the period of the tangent and cotangent is 180 degrees, while it takes a full 360 degrees to get back to where we start with the sine and cosine. Now, it would be a good idea to learn the unit circle and be able to develop these special angles. And really, all that's necessary is to remember this pattern in the first quadrant. And that's a fairly easy one to remember. And then just take care of what quadrant you're in, what is the SIGN or SIGN of the trigonometric function. And these, you can have these anytime you want. Okay, and that concludes this video.